So, good afternoon, sir. We are the group 3 and we are here to present to you the concept map about thermodynamics. So, let's go first to the definition of thermodynamics. So, thermodynamics is a science of relationship between heat, work, temperature, and energy. So, in broad terms, thermodynamics is deals with transfer of energy from one place to another. So, that is mostly the basic concepts, and it is it is also the key concept is that heat is a form of energy corresponding to a definite amount of mechanical work. So, it in this particular topic, which is thermodynamics, it deals with heat being produced in a certain mechanical work or some form of force applied that can cause a heat. So it's a form of energy. Okay. So the first law that we have here in the concept map is the zeroth law of thermodynamics. So when the two systems in thermal equilibrium, which is a third system, two variables that are in thermal equilibrium with a third system, the first two systems are in thermal equilibrium with each other. This property makes it meaningful to use thermometers as the third system and define temperature scale. So what you mean by this is we can picture it as a triangle. So the triangle, which has three sides. So the first two sides or that are connected, this part, the lower part, is actually in heat equilibrium, and in thermal equilibrium, which is they are in the same page or the same reaction to themselves with, and the other one, which is the top one, represents a temperature scale. So that's how they are measured. So they are in unison. So the second law of thermodynamics is the first law of thermodynamics, the law of conservation of energy. So the change in the system's internal energy is equal to the difference between heat added to the system from its surroundings and work done by the system on its surroundings. So, in this first conservation, the law of conservation, it talks about when there is a change in a system's internal energy, and it is has equal to the difference of the heat added to the system from its surroundings. It means that in a specific system there is some change in internal energy, whether it is by mechanical work that can produce heat, and it can be added to the system, and also the system can add and can be receiving heat from the surroundings. So the second part is the second law of thermodynamics. Heat does not flow spontaneously from a colder region to a hotter region, or equivalently, heat is at a given temperature cannot be converted entirely into work. So, to sum this up, heat does not flow spontaneously from a colder region to a hotter region, but over time towards some maximum value. Thus, all closed systems tend toward an equilibrium state, which is entropy. So, it's like we cannot say that heat will travel from a colder region to a hotter region. Instead, it will go to a first it will be in a hotter region, and it will transfer to a colder region. That is how the flow of heat, or entropy, you might call it, of a closed system. So the third law is the third law of thermodynamics. The entropy of a perfect crystal of an element in its most stable form tends to be zero as the temperature approaches absolute zero. This allows an absolute scale for entropy to be established that, from a statistical point of view, determines the degree of randomness or disorder in a system. So, we can say that the third law tends to when this temperature reaches zero, it in an absolute zero, it will really reach zero. And this allows an absolute scale for entropy, which is as that randomness of this or disorder. So they may, when this happens, when the temperature goes to absolute zero, there might be some anomalies in the system, which is the might happen in certain circumstances. So we move now to our equations. So as you may look on the upper right part, that is the zeroth law of thermodynamics. So as I have said, A equals B and B equals C, then A is equal to C. So just like a triangle, they are correlated to each other and they are balanced. The second one is the first law of thermodynamics on the upper left. So the change in the internal energy account and heat added is equal to W, which is withdrawals. So a change in the internal energy account, which is triangle U, is equal to Q minus W. So the second law is in the bottom right, which is triangle S is equal to Q divided by T. So the triangle S stands for entropy, Q is heat added, and T is absolute temperature. Now in the third law, we have the S scale is equal to K log W, where S is equal to entropy, K is equal to Boltzmann constant, and W is equal to number. So as you may see, this particular topic talks about how heat is added to a certain action in a system or mechanical system that can cause several interactions or entropy. So mostly entropy. So that is the presentation of thermodynamics for group 3. Thank you so much.